Hello students, in this lecture we're going to learn about the atomic number, which is having the symbol Z, and it is the number of protons. Now the atomic number is an identification for the element, and the reason for that, no two elements can have the same atomic number. Every element has its unique atomic number because every element has its own number of protons. For a neutral atom, that will also equal the number of electrons. So the atomic number will equal also the number of electrons because that will make the atom neutral. Number of protons are equal to number of electrons. A mass number, which has the symbol A, is number of protons, which is the atomic number, plus the number of neutrons. Therefore, number of neutrons can be calculated if you subtract the atomic number from the mass number. Isotopes are the same element. The fact that I said the same element, what I'm trying also to say that it does have the same number of protons or the same atomic number with different number of neutrons, so they will differ in mass number, but they have to have the same atomic number. Here is a way to write the isotope symbol. X is the symbol representing the element. At the lower left corner, we write the atomic number, and at the upper left corner, we put the mass number. Here are three different isotopes of hydrogen. Note that what they have in common is their atomic number, and what they are different, or where they are different, is really their mass number. So in hydrogen 1,1, that means that the atomic number is 1 and the mass number is 1. And remember, mass number is number of protons plus number of neutrons. The fact that this number is 1, it means that it only has the one proton, but it doesn't have any neutrons. Now deuterium, which is the isotope of hydrogen with a mass number of 2, meaning that I have one proton and one neutron. And when I have a mass number of 3, that means one proton plus 2 neutrons for deuterium, which is another isotope of the hydrogen atom. Now here is a nice picture to show these atoms, and all you can see that the difference is in the nucleus. Hydrogen 1,1, one proton in the nucleus. Hydrogen 2,1 is one neutron and one proton. And the last one, with still one proton to keep it hydrogen, but 2 neutrons. So let's see if we understand isotopes. How many protons, electrons, and neutrons are in carbon 14? And now notice that I called the carbon by the mass number and not by the atomic number. Why? Because if it's carbon, it's known. It has to be 6. You can look at the periodic table, and carbon is the only atom that has 6 protons. So to distinguish it from its other isotopes, I will call it by the mass number because this is where they can be different. So in carbon 14, number of protons is the atomic number, which is right here. You have 6 protons. Since the atom is neutral, then equal number of electrons. And now, if I want to know neutrons, it is 14 minus 6, and that is 8 neutrons. How many protons, electrons, and neutrons are in phosphorus 32? Same thing again. Protons, 15. It's neutral, so electrons, 15. And to get the neutrons, it's 32 minus 15, which equals 70. All good. Here is the periodic table, and this is what we call the with a modern periodic table, I want you to pay attention to the fact that it is color-coded. The beige color is an indicative of metals. The green color is an indicative of non-metals, and what's the zigzag line in the middle between them, that is what we call metalloids, which means like metals. These are elements that have characteristics and properties of both metals and non-metals. Now, on the periodic table, you can find the symbol of the element, in this case, for example, K for potassium, the atomic weight underneath it, and above it or on one of the corners, depending on the periodic table, you will find the atomic number. I want you to note that no two elements on the periodic table will have the same number, right? Because we said that atomic number is number of protons, and if I change number of protons, which is the atomic number, I do change the element. The horizontal lines in the periodic table are called periods, and the vertical lines are called groups or family. So group number is the number you see above here. In this case, this is a group 1A, group 2A. These are the ones we tend to use, by the way. 3A, 4A, 5A, 6A, 7A, 8A. These are the group numbers. In the middle here, we have the B groups, and in Chemistry 1A, we really don't go in depth and talk a lot about the B groups. Group 1A has a common name. It's called alkali metals. Group 2A has a common name, and it's called alkaline earth metal. Group 7A has a common name. We call them halogens. And group 8A are noble gases. The block here under the B groups is what we call transition element or transition metals. Now, do you understand the periodic table? Give the symbol, atomic number, and specify whether the element is a metal, metalloid, non-metal. Also, give the group name. So let's start by iodine. Now, for iodine, guys, the symbol, as you know, is I. And it is in a group 7A, which makes it a halogen. Okay? It is a non-metal. And give the symbol and the atomic number. To get the atomic number, let me show you how we do that. Let's go back and look our periodic table here. If you look at iodine, the atomic number is 53. Okay, so you can get all this information if you spot the element on the periodic table. This is why it's very important that you know the symbols of the elements. Okay, so for the next questions here, what I need you to do, I need you to go over the periodic table. I'm gonna give you hints right now and you need to figure out the rest. You know, magnesium is Mg, gold is Au, and lithium is Li. So go to the periodic table, figure out what is the atomic number, are they metals, non-metals, metalloid, and give the group name if the group happen to have a common name. Now, another definition that we need to understand is the definition of a molecule. Molecule is two or more atoms in a definite arrangements bonded together. Here are examples. Hydrogen is a molecule because it is two atoms of hydrogen bonded together in this covalent bond. Water is a molecule, one atom of oxygen and then two atoms of hydrogen also bonded together. Ammonia is a molecule, a nitrogen atom bonded together to three hydrogen atoms. Methane, one carbon bonded to three hydrogen atoms. Diatomic molecules, from what the name is indicating, are molecules made of two atoms. Like hydrogen 2 hydrogen atoms. Nitrogen gas, 2 nitrogen atoms. Hydrogen chloride, 1 hydrogen atom and 1 chlorine atom. Carbon monoxide, 1 carbon atom and 1 oxygen atom. Polyatomic molecules, these are the molecules that has more than 2 atoms. Examples, ozone. Ozone has 3 atoms of oxygen. Water, 2 atoms of hydrogen and 1 atom of oxygen. Here are the elements that normally exist as diatomic molecules naturally. Hydrogen gas does exist as H2. Nitrogen gas, oxygen gas, fluorine, chlorine, bromine, and iodine, all of them do exist naturally and normally as diatomic molecules. Now, pay attention, you do have to memorize these molecules. Other molecules that also exist in polyatomic, not diatomic anymore, are phosphorus, P4, and sulfur, S8. Okay, now we're going to look at the definition of an ion. Ion is a charged species. So, a cation, ions can be classified into 2 categories. The first category are cations. Cations do have positive charge. Metals tend to be cations and they gain the positive charge by losing an electron. Here is an example. Look at this sodium atom. It does have 11 protons in the nucleus and 11 electrons around the nucleus. When it loses an electron, it will have 11 protons still, but 10 electrons. So therefore, that will make 1 proton extra with a positive charge, which will give sodium that positive charge. So that is a sodium cation. Anions are charged with a negative charge, and they are normally nonmetals, and they gain an electron to become negative. Here is an example. This is here chlorine, 17 proton and 17 electrons. Chlorine tends to gain an electron, so it will have 18 electrons and 17 protons, so 1 more negative charge than positive, which will put the negative charge on a chlorine, so it will become chloride ion, and that is an anion. Monoatomic ions are ions that are made of 1 atom only. Here are examples: sodium cation and nitride anion. What do they have in common? They are ions because they have charges. Sodium is a cation because it does have a positive charge. However, it is made of only the sodium atom, 1 atom. Nitride anion is made only of nitrogen atom, 1 atom, and it does have a negative charge, which makes it an anion. Octet rule is really what controls what kind of an ion will we have, because elements tend to want to gain electrons or lose electrons to have 8 valence electrons. And the reason why they like that, because that will put them to look like the noble gas with the highest stability. Things always go to do things and change to become more stability. I always teach my students stability is the driving force for nature. Valence electrons are the electrons on the highest valence or the highest shell, but right now, since we are going to get into these details later on during the semester, right now you can think of the valence electron equal to the group number of the main group elements. So here it goes. The valence electrons for all the alkaline earth metal equals 2, which is the group number 2A, right? For aluminum, who is in group 3A, the valence number of electrons will equal 3. Valence number of electrons for elements in a group 1A will be 1 valence electron, and so on. Okay? Now the valence number of electrons for nitrogen will be 5, and the valence number of oxygen will be 6, and so on. However, we also can predict charges based on the group. Metals in a group 1A all tend to have 1 plus 1 positive charge. while metals in group 2A will always have +2 charge, and 3A +3 charge. When it comes to metals, charge equal group number clearly. However, for the anion, the non-metal charge will equal the group number minus 8. So look at nitrogen. I just told you that the group number is 5. 5 minus 8 will equal -3. Non-metals want to be anions. They would like to gain electrons. Oxygen in a group 6A. So the charge will be 6 minus 8 will be -2, and so on. Polyatomic ions are ions that are made of more than one atom. Here is an example. Hydroxide is an anion. Why did they call it an anion? Here, I'm going to write it right here. Hydroxide is an anion, right? Because it does have a negative charge, so that's called it an anion. However, the negative charge is on the whole molecule. That's why we call it polyatomic ion. And the molecule is made of more than one atom, in this case 2 atoms, oxygen and hydrogen. Nitrate is a polyatomic ion. It is actually a polyatomic anion because it has a negative charge. And it is made of more than one atom, 3 atoms of oxygen and 1 atom of nitrogen. Monoatomic ions can be, as I said, predictable when it comes to their charges. I did show you how we do it for metals and how we do it for non-metals. However, if you remember, the transition metals, which is group B, can be different and interesting when we get to how they have charges. They tend to be cations, and a lot of them tend to have more than one charge. What does that mean? It means like copper here sometimes can be present as a copper +1, other times it will be present as a copper +2. Iron, it can be present as iron +2 or as iron +3, and so on. Okay? Let's see if we understand ions. How many protons and electrons are in aluminum 27 + 3? Now, protons is the atomic number, clearly 13. Electrons, okay, is it 13? No. Why? The answer is no this time. Because if it has 13, it will be neutral. It does have +3 charge, which means it did lose electrons, and to be specific, it lost 3 electrons. So the neutral atom would have 13, but when you lose 3 of those, that will be 10 left to make this cation. Now, in the case of an anion, let's figure it out. Number of protons is 34, correct? Now, if it's neutral, it will have 34 electrons as well, but it does have a negative charge, and to be specific, 2 negative, which means it gained 2 electrons, so the number of electrons should be 36. What is the formula of phosphorus ion? Phosphide. And how many electrons are present? So if I ever give you a question like that, it means that I am assuming that you will know what kind of a charge phosphorus will take. If you go to the periodic table, phosphorus is in a group 5A. So the charge that phosphorus will take is a group number -8, and that will be -3. So phosphorus will have a -3 charge. Now, in order to know how many electrons does it have, I do need to know the atomic number of phosphorus. The atomic number of phosphorus in the periodic table is 15, but with a -3 charge, it means it did gain 3 electrons, so it will become 18. Okay. Now, how do we write formula of ionic compound? Ionic compounds are neutral, What does that mean? That the ionic compound itself, it does have ion, but overall the compound is in neutral. So we always write the ionic compounds with cations first, followed by anions. And then we never write charges on top of the ionic compound. They should be understood. And the positive charges and the negative charges should be equal because the overall ionic compound is neutral. Here is an example. Let's make an ionic compound. Ionic compounds are normally made of metals and non-metals. And sometimes we can also say they are made of ions because ions can be polyatomic ions. And I will show you examples of both. If I want to make, sodium is a cation that takes a +1 charge, and chloride is an anion that takes a -1 charge. If I want to make an ionic compound between both of them, it will be sodium chloride. No charges on top. I needed 1 sodium to balance 1 chlorine. Therefore, the formula is sodium chloride. Aluminum has a +3. Nitride has a -3. The charges are balanced by having 1 aluminum atom with 1 nitride, or 1 aluminum cation with 1 nitride anion. So this is the formula of aluminum nitride. If the charges are not equal, then you do have to balance the charges and reduce the subscript to the lowest whole number, except with peroxide and mercury. We will talk about that in a specific example. So now let's work on the following compounds together. Magnesium is a metal in group 2A, so it will always have a +2. Oxygen is in a group 6A, so it will be oxide having -2. Now, if I'm going to make a compound between these two, 1 magnesium is balanced by 1 oxygen, and that is the formula of magnesium oxide. Let's go to the next one. Fluoride and calcium. Calcium in a group 2A +2, and fluorine group 7A -1. Now look at that. I have more positive charge than negative charge. How do I fix that? I add another negative charge. So now -2 with +2, that will be balanced. So to make an ionic compound, I need 1 calcium and 2 fluorine atoms. That is calcium fluoride. Magnesium and nitrate. As I said, you can also make ionic compound with polyatomic ions. Let's look at that. Magnesium, as we said, +2. Nitrate is a polyatomic ion with a -1 charge. Now the charges are not balanced. I have more positive than negative, so I have to add another nitrate to balance it. Now I have 2 nitrates for every magnesium. The way I'm going to write the formula, it will be magnesium, and then I will say NO3, and I needed 2 of the whole thing. So this is why I put the nitrate between parentheses. If you don't put parentheses, then it's going to look like this. And the way this can be read in chemistry, that you have 1 magnesium atom, 1 nitrogen atom, and 32 oxygen atom, which is totally wrong. What you have is 2 of the nitrate, and that's why you put the parentheses. Potassium and sulfate. Potassium is group 1A. It will have a +1 charge. Sulfate is a polyatomic anion that has a -2. Now, the balance here does not exist for the charges. There is more negative than positive, so I'm going to have to add another potassium to balance it out. Now look at the outcome. I'm going to have 2 potassium for every sulfate. And because it's 1 sulfate, I do not need to put parentheses. Now this ends this lecture. and I will see you in the next one talking about nomenclature.